The simplicity of hitting run and having your app appear on an emulator hides a lot of complexity. Remember that Android is a full software stack. At its base is a Linux kernel that handles low-level tasks like hardware, drivers, and power management. On top of that are some core C and C++ libraries like libc and SQLite, and the Android runtime along with the core Android libraries. Your app runs within its own instance of the runtime, using the classes and services provided here in the application framework. On top of that sits the application layer, including your app and every other app that's installed. So when you hit run in Android Studio, the first thing that happens is your code gets compiled into bytecode that can be run in the runtime on the device. In Android Studio, this is done using Gradle, a build toolkit that manages dependencies and allows you to define custom build logic. For now, note that we start with your project, which Gradle builds, and then packages the bytecode along with your application's resources, and the externalized images, UI, XML into an Android application package file, an APK, which is a specially formatted zip file. Once you've got an APK ready to go, Android Studio signs it and then pushes it to the device using the Android Debug Bridge, or ADB. If we return to the terminal, you can see that ADB lets you interact and debug apps on any device, physical or virtual. Things like pushing and pulling files, viewing logcat output, or even running a remote shell. So once Android Studio has ADB install the APK, it uses ADB again to launch the app by sending a start command via the remote shell, by identifying the package and class name of your main activity.